In today's problem, we are going to start with a quarter circle with the radius 8. Then we're going to choose the point on the arc of the quarter circle from which we will pull the horizontal and the vertical line like so. Then we're going to connect those two lines to form this really nice triangle. Now inside this triangle we will inscribe a circle with the area pi. The question is, can we somehow calculate the area of this red triangle? I would like to thank one of my subscribers, Danny_math1, for suggesting me this really interesting problem. And if you want to try this problem for yourself, you can pause the video right now and then come back and check your solution. Alright, so let's solve this one. First, we're going to label the center of our quarter circle as O, and we're going to label all the vertices of our triangle as A, B, and C. Now, let's have a look at the line BC. From the condition of our problem, we know that this is a vertical line. So that means that this line will be perpendicular to the horizontal radius of our quarter circle. The same thing applies for the line AC. Since this is a vertical line, it must be perpendicular to the horizontal radius of the quarter circle. And since those two lines are horizontal and vertical, this means that the angle between them must be a 90-degree angle. So now if we take a look at the quadrilateral OACB, we can conclude that this quadrilateral is actually a rectangle. Now let's have a look at the radius of our quarter circle and let's rotate it to the point C. You can now clearly see that this radius will represent the diagonal of our rectangle with the length of 8. But since we know that both diagonals of the rectangle are congruent, this means that the line AB will also have the length of 8. Alright, so let's go back for the moment and let's label the horizontal leg of our red right triangle as A and the vertical leg as B. Now we can form the Pythagorean theorem. We can say that A squared plus B squared is equal to hypotenuse 8 squared, and of course this means that A squared plus B squared must be equal to 64. This will be our first equation. Now let's try to find another one. Let's go back and take a closer look at our circle with the area pi. We know that the area of the circle can be calculated as r squared pi. But since we know that the area of our circle is pi squared units, we can just cancel pi's and get that r squared is equal to 1, which means that the radius of this circle is equal to 1. Now let's go ahead and pull the horizontal radius of our circle. We will now use the tangent of a circle theorem, which states that if we have a circle and the tangent line to this circle, this tangent line will always be perpendicular to the radius which goes to the point of tangency. So we will use this in our favor here, since the line AC is a tangent to our circle and our horizontal radius goes to the point of tangency. So those two lines must be perpendicular. The same thing will apply if we rotate our radius vertically. Of course, now the line BC will represent the tangent and our vertical radius will go to the point of tangency, so both of those lines will also be perpendicular. Alright, so now let's mark both lengths of our radii as 1, and let's proceed by first sliding the vertical radius to the right, like so. We can also slide horizontal radius upward and get something like this. From this sketch, you can probably notice that we can find the rest of the line AC as the difference between the length of the line AC and the length of our radius, which means that the length of this segment is equal to B minus 1. We can do the same thing for the rest of the line BC, as it will be equal to the A minus 1. Now we will use one really interesting property of a circle that states that the length of a tangents from an external point to a circle are equal. We will first use this property on our yellow line with the length of b minus 1. If we pull this line on the other side of our circle, you can see that we have formed two tangents from an external point A. So this means that those two tangents have the same length of b minus 1. Now we will do the same thing for our blue line with the length of a minus 1. We can pull this line on the other side of the circle and you can see that again we have formed two tangents from an external point B to our circle. So both of them will have the length of a minus 1. Now let's go back and focus our attention to the line AB. This line has the length of 8. But it also has two segments with the length of a minus 1 and b minus 1. So we can say that a minus 1 plus b minus 1 must be equal to 8. Now we're going to work through this and finally get that a plus b must be equal to 10, and this is our second equation. Now we're going to use these two equations to form the system of equations. You can use multiple ways to solve this, but for this video I will use the method of finding the perfect square from our first equation. I will first add and subtract the value of 2ab. From the point of equilibrium, this will not change our equation. But if we group our first three terms, you can clearly see that those three terms will form the formula for the square of binomial a plus b squared. So, the quantity of a plus b squared minus 2ab is equal to 64. Now, since we already know that the value of a plus b is equal to 10, we can substitute this one in and get the following. We can work through this equation and get that 2ab is equal to 36, which means that a times b is equal to 18. Now, remember, we are looking for the area of the right triangle with the legs a and b. And since we know that the area of the right triangle is equal to the half of the product of its legs, we can just substitute our value a times b and get that our red area is equal to 18 over 2, which means that our wanted red area of the red triangle must be equal to 9 squared units, and this is our solution. Well, I hope you enjoyed this interesting problem. If you did, do not hesitate to leave a like and consider subscribing to the channel for more content like this. Of course, if you found another way to solve this problem, please write it down in a comment section below. And until next time, see you all and take care.